Okay, so just to kind of put this together to simplify this process, I think this has been a kind of a challenging approach to things, but not really, because the reality is we actually know how to do this. It came in a new form and then it kind of like made us panic and freak out. So let's first, before we get to talking about like, oh, well, how do we find area of like these shapes that aren't quite in terms of arrays, let's talk about what we know about area. This is something we are all really good at. Like we rock this because we do understand that area is this array, right? It's talking about how much space this array takes up. And because this array is made of rows and columns, that was the start of it all. And so if we go back to the very beginning when we're talking about like multiplication and things, right? Like someone said, oh, well, if I had 3 times 2, what that meant was I had 3 rows of 2. So I could say 1, 2, 3. Oh no, 3 rows of 2, excuse me. So 1, 2, and 3. And that is what really makes the array. It's these perfect rows and columns where everything's equal. And so why this works as area is that we do know that 3 times 2 is 6, and that's true. Look, it actually makes 6 squares. 1, 2, 3, 4, 5, 6. And the distance around these points here that we talked about on a coordinate, right, make this rectangle. And then we can find the measurement of this rectangle by knowing its area. And I could count my squares, but what we do know is that an array is just skip counting, which is true, because in this case, I have 1, 2, 3 groups of 2, which gets me 6. So for area, we know that if we have a rectangle or a square, I can take the length times the width of that square to get area, or I can take the rows times the columns. Now, what happened with this skill here that was so much is that now these weren't arrays. In fact, I don't even know what that was. I was just drawing something, draw another one. Right? These are not arrays because they don't have this perfect row and column like we do here. I don't have these equal groups. I don't have 3 groups of 2. In fact, when I look at this, I have all sorts of funky things going on. Like here, maybe this is 10 inches, which is true, meaning across this piece here, right? Across this piece here, I might have 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. I did that, right? I might have 10 units here. But what's irregular about it is that along this side, from here to here, right? Maybe that this is 12, right? So maybe I have 12 units along here. Really accurately draw that. Right? I might have 12 here, but the reality is I have 12 from here to here. I don't have 12 from here to here. So again, this is an irregular array. I can't just say, oh yeah, well then it's 12 times 10, because actually out here, right, that those 12, they don't exist. They're gone. They weren't there because it's not a rectangle. It's not a rectangle or a square. So that's why when we get these larger shapes and we have all these numbers, we can't just take the numbers and multiply them. So if this was 10 and this is 12, maybe this is, there we go. Maybe this is 6 and this is 6, and this is 7 and this is 3, right? Like maybe we have I can't just multiply them all because that just, oh, actually, I guess technically, if you count here, 1, 2, 3, 4, this would be 4, right? And this would be 1, 2, 3, 4, 5, 6. Okay, sorry, my fault. And this would be 1, 2, 3, 4, 5, 6. Okay, good. So that kind of worked out, right? But regardless of whatever the measurements are, like I can't just take all those numbers and multiply them together. So how do we solve these problems? Because the reality is, in order for me to multiply length times width, I have to have a rectangle or a square, because a rectangle or a square is an array. So that's the very first challenge. So let's break this down into 3 steps to make sense of this. 1, you have to find arrays or, rectangles or squares in the shape you have. So you have to find them. So again, I'm going to draw one of these shapes, and this is one of the most common ones. I know we keep seeing the same one, but they do look different, but we won't get there. So I want to find them. So let's throw some measurements on here just to make sense of it. I'm gonna go quickly because I don't want this to go on too long. No, see already. It's like, go quickly. Let's make this 7. Okay, so, and then this one right here. Okay. And we'll just call these units for now. Feet, whatever. We're just going to call them units. Okay. So this is what it'd be. So the first thing I want to do out of this is, like, I recognize I don't have rectangles or squares, but I can find some. I can make some. And what I mean by that is I can imagine that if I just drew a line here, right? If I just went along this axis, right, on a coordinate grid, like, let's not forget all that work we've done about a coordinate grid, right? Like, let's just say that this line right here on this coordinate grid goes on forever, right? So if I just draw this line on this coordinate grid, you'll see what happens is I actually get 2 different rectangles. I get this rectangle right here, and then I get this rectangle down here, right? Do you see how now I've actually made arrays just by drawing that line? What I now see, especially in this blue one down here, I see I have a complete column and rows. And same thing with this orange one here. I have a complete columns and complete rows. There's nothing missing. They are equally out and put together. So once I've done that, once I've found my arrays, then what we need to just do is find the area of each of them. So that's step 2. So find the area of each of them. So that just takes organization. What I like to do is I just call this one 1 and I'll call this one 2. And then I organize it. I say, okay, well, the area of rectangle 1 is going to be something times something equals something, right? Equals the area. So these somethings over here, these are my rows and my columns. Well, if I look at this rectangle here, right, I do see that right here, this point from here to here, the distance between that is 5. So that's how many rows I have. Technically, what that's saying is there's 5 units going across my rows. So I have 5 units. And then I'm going to multiply that by the distance between here and here, my columns, which says, well, technically I have 6. And so to find the area of this entire thing, which now I've done in orange and pink, so I'll go back over it in orange, to find this whole area, like how much space this takes, right? If I colored in the whole thing, colored in all those squares, I would end up with 30 units squared. Okay. Now, again, what's tricky about this is we have all these other numbers, and sometimes those numbers don't matter. And that was the thing I think yesterday was the challenge is here. This 10, which is the distance of all this here. I don't think this is going to matter for our work today. So I'm just going to let that one go. But I am going to come back and say, okay, well, now I have rectangle 2, which is, I'm going to now stick to blue. And with blue, it's the same thing. I have rows times my columns equals the area. I'll erase this now, since I said, hey, we won't need it. Watch, we're going to need it, and I might forget. But we won't, because look, my rows, which is up and down, right? The x-axis of things is the same measurement of here to here. And that's labeled for me. It's 5. There's 5 rows, just like there were up here, actually. What a coincidence. And then my columns, right? My columns can come from the bottom. Like it would be this distance up here, but it's messy up here. Look at all the stuff that's going on. So I'm going to look at this right here, which is my width. And what it's saying, right? What it's saying is my columns, I have 13. So now I'm just going to multiply that. So 5 times 10 is 50. And then 5 times 3 is 15. So that gets me 65 units squared. Yep. Okay. So those would be the first 2 steps, right? 1, find the arrays in there. And then step 2, find the area of each array. And then if now I know the area, right? This is, oops, wrong thing. If this is 30 units squared and this is 65 units squared, well, if I want to know the area of all of it, then all I'm going to do is my final step. I got confusing. 1, 2, 1, 1. Maybe I should call it this A and B. Let's do that. A and B. Okay. Now my final step, step 3, is I just want to add my areas, because that's going to be my final answer, right? I'm going to take the 65 units squared from the blue, and I'm going to add it to the 30 units squared of the orange. I'm going to get 95 units squared. I'm going to rewrite that answer somewhere. So let's see down here. Let's say area is equal to 95 units squared. Okay. So that's really what we're doing in this process. It's a 3-step process. 1, find your arrays. Draw a line so that you're actually making rectangles and squares. 2, find the area of all those different rectangles and squares you found. Sometimes it's 2 of them. Sometimes you might have to cut it so there's 3. Sometimes 4. I don't know. It just depends. And then 3, once you have the area of each part, then add all those parts together to get the total area of the entire shape. Okay. So that's it. I was trying to leave that brief. If you think about following those steps with the independent work, it is going to make more sense. And I think eventually through practicing it, you're going to be like, oh, okay, I totally get it now. And if not, that's fine too. Keep asking questions because that's the goal. All right. Thank you for your time. We'll catch you later.